This is the third part on chapter on matrices. We had already seen addition and subtraction of matrices and also multiplication of a scalar quantity with a matrix. Now you are going to see how to multiply two matrices. Okay. So multiplication of matrices. Two different matrices you are going to take and multiply. Multiplication is not as easy as addition or subtraction. Okay. Now, I have given you an example here. A is a matrix whose elements are 2, 3 and 5. And B is the second matrix whose elements are 4 and minus 6. The first thing that you have to check is whether multiplication can be done with these two matrices. That is, whether you can multiply matrix A with matrix B. Okay. For that, you have to know the order of both these matrices. Once you know the order of these matrices, using the orders, you will have to find whether multiplication is possible or not. So that's what I'm going to show you first, whether you can multiply these two matrices or not. Okay. So let's first check whether you can multiply these two matrices or not. For that, let's find the order of A and B. Let's say, for example, you're going to find AB. Multiply A with B. Okay. So A is a matrix. I'm taking A. You see, what is its order? Order means number of rows by number of columns. So A has, that's first row, second row, third row. So A has order 3 is the number of rows by, you see how many columns it has. Okay. It has one column. So A is a 3 by 1 matrix. A has 3 rows, so that 3 is here. By, it has 1 column, so by 1. This is about A. Next, about B. You can multiply B. Okay. So let's write down the order of B. Let's see what is its order. See how many rows B has. This one has how many rows? There is only one row. Okay. So B has one row. This is the row. So it has one row. Okay. By, you see how many columns it has. Okay. Columns are these. That will be the first column. That is the second column. So it has 2 columns. So A's order is 3 by 1. B's order is 1 by 2. Their orders are not same. They don't have the same rows and same columns. Okay. But you also have to check whether you can multiply them or not. So to check whether two matrices can be multiplied, look at the order. If, see this, these are rows of the first one, rows, and these are columns of the first one. And these are rows of the second one, and these are columns of the second one. Matrix multiplication is possible only if the columns of the first matrix and the rows of the second matrix are the same. Columns of the first matrix and rows of the second matrix are the same. I'm just going to put a rectangle around this. This is what you have checked. Whether these two numbers are same. That is, columns of the first matrix and rows of the second matrix. Are these two numbers the same? If it is same, then you can multiply the two matrices. So in our case, this is 1, therefore you can multiply the two matrices. So matrix multiplication is possible. Matrix multiplication is possible because since columns of first is equal to rows of the second matrix. That is, these two numbers are same. Okay, columns of first matrix and rows of the second matrix are same. If they are same, matrix multiplication is possible. You can multiply both the matrices. Now, the answer that you will get by multiplying A and B, you will get AB. Okay. The order of AB, the order of the resultant matrix that you are going to get by multiplying A with B, the order of that will be rows of the first one by columns of the second one. The order of resultant matrix is rows of first by columns of second. So order of the resultant matrix in our case will be rows of the first one, which will be 3, by columns of the second one. Column of the second one is 2. So the answer that you will get will be a 3 by 2 matrix, which means it will have 3 rows and 2 columns. Okay. So whenever you look at 2 matrices, first thing that you have to check is whether you can multiply them. To check that one, write the order of A, write the order of B, and see whether these 2 numbers are same. If these 2 numbers are same, means you can multiply the 2 matrices. And the result that you get by multiplying will be of the order rows of the first matrix by columns of the second matrix. So that will be a 3 by 2 matrix. Okay. Now, let's see how to multiply them. Say, we are going to multiply A with B, which means matrix A comes first. Okay. Matrix A is 2, 3, 5. So that will be 2, 3, 5 into matrix B. Matrix B will be 4 and minus 6. 4 minus 6 like this. So how to multiply these 2 matrices is you have to multiply the first row of this matrix with the first column here. A row of the first matrix and a column of the second matrix. So first row with first column. Okay. So this is what you're going to get. First row with first column, which means you're going to multiply 2 with 4. 2 into 4. Because you use the first row, you will write the answer also of the first row. Okay. Then first row with first column is done. Next, first row with second column you have to multiply. First row with second column. Because you are using the first row, the answer must be of the first row. Because you are using the second column, the answer must be of the second column here. Okay. So 2 into minus 6. 2 into minus 6. So first row with first column we multiply here. First row with second column we multiply and wrote it here. Next, you have to use a second row with first column. 3 with 4. Because you are using the second row, your answer must be of the second row. Okay. So that is 3 into 4. So 3 into 4. And again, second row with second column you have to multiply. Second row with second column. You are using the second row, answer must be of the second row. You are using the second column, which means answer must be of the second column. So 3 into minus 6. 3 into minus 6. So first row is done. Second row is also done. Now there is a third row. This one. Multiply the third row with first column. That is 5 with 4. So 5 into 4. So that is first row with first column. Because you use the first row, third row, your answer is of the third row. Because you use the first column, answer is of the first column. Again, you multiply 5 with minus 6. So 5 into minus 6. 5 into minus 6. Your multiplication is complete. Okay. So let's write down the answer. That's 2 into 4, that's 8. 2 into minus 6 is minus 12. 3 into 4 is 12. 3 into minus 6 is minus 18. 5 into 4 is 20. And 5 into minus 6 is minus 30. this will be the resultant matrix. As I told you, the resultant matrix must be of this order. It should have 3 rows and 2 columns. 1, 2, 3 rows and 2 columns. 3 rows, 2 columns. That is AB. Let's check whether we can multiply B with A. A with B was possible. Let's try it and see whether we can multiply B with A. Okay. So for that, let's take B and A. Order of B, this one, order of this, 1 row by 2 columns. This has 1 row by 2 columns, and A's order is, it has 1, 2, 3 rows by 1 column. First check whether you can multiply them. That is, if these two numbers are same, then only you can multiply. Are these two numbers same? No. This is 2, this is 3. They are not equal. Therefore, this multiplication is not possible. Multiplication is not possible. Because columns of the first one and rows of the second one are not the same. Therefore, you can never multiply B with A, but you can multiply A with B. Okay. So that's an example of how you're going to multiply. Now, for certain matrices like this, A is a 2 by 2 matrix, A is a 2 by 2 matrix, B is also a 2 by 2 matrix. For this, there is no need for you to check anything because these two numbers are same. The result also will be a 2 by 2 matrix. So in such cases, there is no need for you to check. If it is a 2 by 2 matrix like this, A is 1, 2, 3, 4 and B is 3, 2, 1, 0. Both of them are 2 by 2 matrix. 2 rows, 2 columns. This also has 2 rows, 2 columns like this. And these two numbers are same, that is columns of the first matrix and rows of the second matrix are same. Therefore, you can multiply these two and the answer that you will get will be the extreme numbers. Okay. It will also be a 2 by 2 matrix, something like this. 4 elements will be there. Okay. So in these cases, there is no need to check. Only if both the matrices are different from each other, then it is necessary for you to check and see whether you can multiply or not. Okay. Next, this is an example of a 2 by 2 matrix with another 2 by 2 matrix. So as I said, for a 2 by 2 matrix, there is no need for you to check whether you can multiply or not. You can multiply it. So let's find AB. That is A, 4 minus 3, 2, 1 has to be multiplied with B, minus 1, 2, 0, 3. As I told you, when you multiply two matrices, you multiply rows of the first matrix with columns of the second matrix. So, let's see how to multiply. Let's take the first row. This is the first row. And multiply this with the first column. First row with first column. And you write the answer here. First row, first column. So that is 4 has to be multiplied with minus 1. 4 into minus 1. And in between, after multiplying this with this, you have to multiply this with this. And in between you have to put a plus sign. Always put a plus sign. So plus. Next multiply minus 3 with 0. Minus 3 into 0. Once more. 4 with minus 1, that is here. And you put a plus sign in between and multiply the second ones. That is minus 3 with 0. So first row with first column is done. Next. First row with second column. Okay. So this is the first row with second column now. That means you have to multiply 4 with 2 and minus 3 with 3. And in between you have to put a plus sign. So 4 with 2, 4 into 2 plus minus 3 with 3. into 3. Now why I wrote it here is I am using the first row, so answer must be of the first row. I am using the second column, so answer must be of the second column. Okay. So first row with first column is here. First row with second column is here. Next, let's take the second row. Now second row with first column, that means you have multiplied 2 with minus 1 and 1 with 0. Okay. So 2 with minus 1, that is 2 into minus 1, in between plus 1 with 0, 1 into 0. So second row first column is done. Next, second row with second column you have to do. Okay, second row with second column. So this with this. So 2 into 2 and 1 with 3, and in between you have to put plus sign. So 2 into 2, 2 into 2 plus 1 into 3, 1 into 3. Your multiplication is over. Now simplify this. That will give you 4 into minus 1, minus 4, plus this into 0 is 0. 4 into 2 is 8, and minus 3 with 3 is minus 9. 2 with minus 1 is minus 2, and 1 with 0 is 0. This into this is 4, and 1 into 3 is 3. Simplify and write the answer. So that will give you minus 4 plus 0, which is minus 4. 8 minus 9 is minus 1. That's minus 2. And the last one is 7. This is A into B. Okay. This is A multiplied with B. You can also multiply B with A in this case, because both of them are 2 by 2 matrix. B with A, when you multiply, it will not give you the same answer as A with B. It will be slightly different. Okay. Because your rows and columns are going to change. First you are going to use B, then you are going to use A. Therefore, the result will be slightly different. Okay. So, this is how you multiply two matrices. Next, from exercise 10, question number 11. Find x and y if this matrix is multiplied, no sign, therefore multiplication, multiplied with this matrix equals a third matrix which has elements x and y. And x and y are the values that you have to find. Okay. So I have written whatever is given, that is first matrix multiplied with second matrix gives you this is the result. So let's do the multiplication. This matrix has to be multiplied with this matrix, which means you have to multiply first row with first column here. So you have to multiply 1 with 3, 1 into 3, and in between you have to put plus. 0 has to be multiplied with 4, 0 into 4. So first row with this column is done. First row with there is no second column. Okay. So you don't have to do that. Next you do second row with this column. That is 0 has to be multiplied with 3 and minus 1 with 4. Because you are doing the second row, write the answer in the second row. Okay. So 0 with 3, that is 0 into 3, then in between plus, minus 1 into 4, minus 1 into 4. So first row with first column is done here, second row with this column is done here. That's all. Your multiplication is over. Close this is equal to x, y. Simplify this. 1 into 3 is 3 plus this is 0, that's 3. This is 0 and this is minus 4. 0 minus 4 is minus 4. Is equal to x, y. The two matrices here are equal, which means first element must be equal to first element. Therefore, x is equal to, first element here is 3. And y is equal to, whatever y is here, should be equal to this one. That's minus 4. Okay. So these are the values of x and y. Next question. Question number 15 from exercise 10. If P is this matrix and Q is this matrix, then compute subdivision 1, P squared minus Q squared. Let's find this first. We'll go to the second subdivision later. Okay. We have to find P squared minus Q squared. That's the first subdivision. P squared means P multiplied with P. So what I have done is this is P multiplied with another P. So that is P squared minus Q squared means Q multiplied with Q. This is Q, this is also Q. Q into Q. So let's multiply this. So when you multiply this first row with first column, which means 1 has to be multiplied with 1 and 2 with 2. So 1 into 1 is 1 plus 2 into 2 is 4. Next, first row with second column, that one. Which means 1 into 2 and 2 with minus 1. 1 into 2 is 2 plus 2 into minus 1 is minus 2. Then use second row with this first column. That means 2 has to be multiplied with 1 and minus 1 with 2. 2 into 1 is 2 plus minus 1 into 2 is minus 2. Then second row with second column. Second row with second column. It means 2 into 2 and minus 1 with minus 1. 2 into 2 is 4. And minus 1 into minus 1 is plus 1. So this is complete. You multiply P with P. Then minus. Now let's multiply Q with Q. Same thing. First row with first column. That means 1 into 1, which is 1, plus 0 into 2, which is 0. Then first row with second column. So we are going to use the second column now, that one. Which means 1 has to be multiplied with 0 and 0 with 1. So 1 into 0 is 0 plus 0 into 1, which is also 0. Next, let's use the second row with this first column. 2 into 1 and 1 into 2. 2 into 1 is 2 plus 1 into 2 is also 2. Next, you will use second row with second column, that is 2 into 0, that's 0, plus 1 into 1, that's 1. So that's complete. Close the bracket and simplify this. This is 5, next 0, 0, 5, minus, that's 1, 0, 4, 1. And subtract these two matrices. Subtraction is easy. Here you have to take each element now. 5 minus 1, that's 4. This is not multiplication, subtraction. So 5 minus 1, that's 4. Then 0 minus 0, which is 0. 0 minus 4 is minus 4. And 5 minus 1, that's 4. So this is P squared minus Q squared's value. The first subdivision. The second subdivision of the question is you have to find P plus Q into P minus Q. So let's do that one. P plus Q into P minus Q. Second subdivision, P plus Q into P minus Q. Let's put the value first. P plus Q first. Okay. So I'll use like this bracket. First P. So P is here, this is P, 1, 2, 2, minus 1. One, two, two, minus 1. That's P plus matrix Q. Matrix Q. Okay. Matrix Q is 1 0 2 1. And into P minus Q. Again, same thing. 1 2 2 minus 1 minus 1 0 2 1. So what you have to do now is look at the first bracket, add these two matrices. This is addition. So 1 plus 1, which will give you 1, 2 plus 0, which will give you 2, 2 plus 2 will give you 4, minus 1 plus 1 is 0. That's done. Into, subtract this, 1 minus 1 is 0, 2 minus 0 is 2, 2 minus 2 is 0, and minus 1 is minus 2. Now the sign in between here is multiplication, therefore multiply the two matrices. Okay. So we'll go by rows and columns now. First row with first column, that is 1 into 0, which is 0, plus 2 into 0, which is also 0. First row with first column is done. Next, first row with second column, this one. So 1 into 2 is 2, plus 2 into minus 2 is minus 4. Next, second row with first column, that is 4 into 0 and 0 into 0. 4 into 0 is 0, plus 0 into 0 is also 0. Then, second row with second column, 4 into 2 is 8. And 0 into minus 2 is 0. This one is complete. Simplify this. That's 0. 2 minus 4 is minus 2. 0 and 8. Now there is a third question. This is P plus Q into P minus Q. There is also a third question. If you look at the third question, is P plus Q into P minus Q equal to P squared minus Q squared true for matrix algebra? For normal algebra, this is correct. P plus Q into P minus Q gives you P squared minus Q squared. That's a normal algebra. But whether this is true in matrix algebra or not, let's check and see. P plus Q, is it equal to P squared minus Q squared? You already know P squared minus Q squared is this 4 0 minus 4 4, and this one's answer is 0 minus 2 0 8. Is this and this equal? So according to matrix algebra, it is false. So usually, only in rare cases you will get both these matrices equal. So therefore, P plus Q into P minus Q is not equal to P square minus Q square in matrix algebra. So that's the last part. And your homework is from exercise 10, question numbers 17, 21 subdivision 1, 25 and 40.